Now let's look at sets, which constitute a different type of collection. Assume we want to develop an application which will find a specific word in a book. How can we implement this? One thing that comes to mind is you create a list and put all the words you see in the book in the list. Then for this word that you're trying to find, just try to find it in the list. Would this be a good implementation or a bad implementation? Remember that from now in this course, we're trying to find the better solutions rather than any solution. Is the order of the words in the book important for us? Because we're just trying to find if that word appears in the book or not. So we don't care about the order. So if we don't need the order, which means we don't need an index of the elements, then we also don't need duplicate values now, which means, for example, the word the, for example, probably appears many times in the book. So we just need to know if it appears or not. We don't care about how many times it appears, at which order they appear. So we need a different data structure. Definitely list is not the best solution for this, because if you want to search for the existence of a word in this list of words, it will take a long time to search for it. So Java provides a new data type for this purpose, which is the set. So let's very briefly talk about the let's first talk about the abstract data type for set. Sorry. So a set is actually an unordered collection where we don't have any duplicates, which means each element occurs only once, not more than once. So the main purpose of having a set is to be able to search an element to see if it's a member of the set or not. So we need a method as contains. We will define sets as set of, again, some generic type E, where E is anything again. It could be string. It cannot be int, because int, remember, is a primitive type, but it could be integer, which is the wrapper class of int. It could be a set of points, a set of anything that you define, even the classes you define, just like the case of list. Also remember in the hierarchy that set is an interface, which means you cannot create objects, instances of set. So saying new set is not legal. Although set is an interface, it has two different implementations in Java. One is TreeSet and the other one is HashSet. So we will be talking about creation of new sets, so TreeSet, so we will say new TreeSet, that's fine. New HashSet, that's also fine. But saying new set is not acceptable. But as we did with the list, for example, you can define a variable or a parameter of type set, which can accept an object of type TreeSet or HashSet, because these two implementations are both implementations of the same set interface. These two different sets are, since they're interfaces of sets, they provide the same functionality, but Java has implemented these two classes in slightly different ways that are optimized for specific purposes, which we're going to discuss. So set, remember, is still a kind of collection. So at the top we had collection, which could be either a list or a set. So set is a different kind of collection. We said it can be implemented as a tree set or a hash set. So you can define, for example, a variable with the name set of type set of integer. That's fine. But as I said, You cannot say new set, but you can say new TreeSet of integer. Note that among the functionalities we discussed, there is nothing related to index. We said there is no order of the elements in the set. Therefore, methods like get the element at index whatever is not legal. Set does not provide such methods. Similarly, you can add elements, you can add a value to a set, but you cannot add it at a specific index, which means add in parentheses value is valid, but add in parentheses index comma value is not valid. Also, you cannot remove an element according to the index. If the elements of the set are not ordered, then one problem is how do we access the elements? Because we said we cannot use get to access the elements. Also, we cannot use remove index to remove the elements. What we can do is we can make use of the iterator. Because the iterator, although there is no index, it will start with an element. And when you say next, it will visit an element that has not been visited before, then another, until it has visited all of the elements. And once it has visited all elements once, iterator cannot continue. So when you use the next method of iterator, you will get a false value as the return value. Now let's look at an example that uses sets. Assume that we want to create a set of strings named stooges into which we put strings names. We define, as you can see in the example, we define stooges as a set of string, not as a hash set or tree set. But then when constructing the object, we prefer to implement it as a hash set. So we construct an object of type hash set, but put it into a variable of type set. We could have done the same thing by just a similar thing by just saying here TreeSet. Still it would work, but the outcome would be slightly different, as we will see. So going with the hash set example, now we can call the add method on stooges on the set, but note that we're just providing the value, no index, because in the set we have no index. So in this order, we're adding the values Larry, Mo, Curly, Mo once again, Shemp, and Mo for the third time. See that the second and the third insertions of Mo are duplicates, and Java will not give any error for this, but it won't do anything either. It will just ignore this because the set already contains Mo, it was added here, and further attempts to add the same content will just be ignored. And finally, when you try to print the whole set on the screen, you will see, for example, Mo, Shemp, Larry, Curly. Note that if you just use this code in your system, you might see them in a different order. That's also fine. I will explain why. But one thing you need to note is this order is actually different than the order we entered. We entered Larry, Mo, but we have Mo, Shemp as the first two elements. It's not the alphabetical order either. It's not the inverse of the alphabetical order either. So what is this? Actually, what happens here is the following. That's the important thing about hash set. In the case of hash set, Java creates hash values for these strings. We will later discuss what a hash value is in the chapter of hashing, but it will create some values, some integer values that represent some characteristic of these strings. For each one, it will be a different value, and those values need not be in increasing or decreasing order for something that you can give a meaning to. So it is, we said, not the order of entrance, not the alphabetical order, not the number of letters. It's just there's some mathematical function running over the string and creates a value, which we call the hash value. These are according to the hash values. And that's something, as I said, which doesn't make any sense for you, and actually it's not important for us if you're using hash set. Okay, the important thing is hash set is a set that works very fast. That's why we prefer hash set. However, there will be cases where we want to see them in an ordered manner. So the only thing you need to change in the previous code is instead of hash set, you will just write TreeSet. Remember, the variable itself was of type set, so we could assign a TreeSet object to a set variable. The add method, the call of the add methods would be the same, so this part would be the same. Printing it on the screen, that would also be the same. So as I said, the only thing that you need to change is instead of hash set, you write here TreeSet, and the output suddenly becomes curly Larry motion, which is actually, as you can see, the alphabetical order. So the difference between a TreeSet and a hash set is a TreeSet stores the elements in an order. Now in this case, it's a set of string, therefore it will be the alphabetical order. If it was a set of integers, that would be the integer order. Or if it's, say, set of students, it depends on the compare to method. Remember we discussed the compare to method? So it depends on the result of the compare to method. So it will be calling, TreeSet will be calling the compare to method you have implemented to see which one comes before or after the other, and they will be sorted according to that order. But in the case of hash set, it's not looking at those. It's not looking at the ordering. It just creates the hash values and manages things accordingly. As we said, hash set is the fast implementation. Therefore, TreeSet is the slightly slower implementation. Typically, you will not feel the difference when your sets are small. But when you have large sets, then you will realize that actually hash set runs faster than TreeSet. So it depends on really how large your set is, and also if the order of the elements in the output is that important for you or not. Now, this you will remember from elementary school, but the concept of set, remember, is also valid in mathematics. Actually, we can map it also here. So consider two sets, A and B. Remember, A union B is the blue part. That's both A and B. Intersection is the part which is the subset of the elements that are elements of both sets. And the difference is the set of elements that are in A but not in B. So it's actually the intersection subtracted from A itself. So how can we attach these ideas to Java? Well, to check if something is subset of another one, say we have two sets, S1 and S2. So if, for example, you want to check if S2 contains every element of S1, in other words, if S1 is a subset of S2, what you can do is you can call the contains all method of S2, and as the parameter, you give S1. What I mean is the following. You write like this. Just 1 second for me to get the pen. So you can write something like S2 that contains all S1. For example, you can put this in an if statement. Note that you're calling the contains all method of S2. So we are asking if S2 contains all of S1. So if all elements of S1 appear in S2, this will return true. This doesn't necessarily mean that S1 and S2 are equal. S1 could have sorry, S2 could have elements that do not appear in S1, but the important thing is all elements of S1 appear in S2. So that will find us, that will tell us whether S2, sorry, S1 is a subset of S2. What if we want to take the union? To take the union, you can write, for example, S1 dot add all S2. When you write this, all elements of S2 will be added to S1. If some of those elements already appear in S1, no problem, they will just be ignored. But if there are elements of S2 that do not appear in S1, now they will be added to S1 because you're adding all elements of S2 to S1. Note that at the end of this function call, S1 will be modified, but S2 will remain unchanged. So the elements of S2 do not disappear. It doesn't become the empty set. But S1 gets modified. So that's something you should pay attention to. For the case of intersection, you can write S1 retain all S2. Remember, retain means keep. So keep all elements that appear in S2 in S1. So keeping them means remove the others. Okay, so S1 will get updated such that elements of S1 that did not appear in S2 will be deleted from S1, but the elements that appear also in S2 will remain there. So you will find the intersection. So it will just be like if this is if this is S1 and this is S2. Sorry, let me just erase that. Oops. Sorry, I could select the eraser. Okay, here we go. So elements of S1 that appear in S2 are here. These will remain, but the elements of S1, the dotted ones, that are not in S2 will be deleted. So all you will be left with will be the crossed or dashed part. So you have the intersection at the end. So again, note that S1 gets updated, nothing happens to S2. And the difference is just the inverse. If you just say S1 remove all S2, all elements of S1 that are also elements of S2 will be discarded. So this time, if this is S1 and if this is S2, the elements here that are also elements of S2, they will be deleted. All that remains will be this part, which is actually S1 difference S2.